Okay, so our problem isn't when we say it's benign morphologically. Our problem is when we're suspicious of the lesion. A significant cohort of those will turn out to be benign. Look, let's return to the notion of Doppler sonography for a moment. We've said that benign lesions would tend to have high resistance and malignant lesions would tend to have low resistance. Typically, the line of division between high and low resistance is usually a resistive index of 0.4. So here we've drawn that line. In this study, we took a whole bunch of lesions and measured the mean resistance in the benign and the malignant lesions. And virtually every study on this shows the same thing, that benign lesions have a higher mean resistance than malignant lesions, and the distance between those two means is statistically significant. That fact and $1.75 will get you a tall coffee at Starbucks. Statistical significance is one of the things that drives me crazy in the medical literature. Look, statistical significance only means that the results of this study probably were not on the basis of chance. We didn't just flip a coin and get these results. So clearly, papers that do not show statistical significance are probably not useful, but papers that do show statistical significance doesn't mean that they are clinically useful. And frequently, they are not clinically useful, whereas a single case report might be extraordinarily useful to you during your day's work. So, yes, benign lesions have a higher mean resistance than malignant lesions. I do not consider that clinically valuable, and I felt that I knew why, so I did this study. We looked at patients who were going to go to the OR to have their mass removed, and we took many samples of resistive indices in the mass. This was a 65-year-old woman with this very large ovarian mass, typically mucinous. It had thick septations. It had a large mural nodule. She's a woman with an a priori risk of greater than 50% for having a cancer. So we would clearly, on the basis of morphology, think of this as cancer. We measured a resistive index in this portion of the lesion, and it was extremely high. And we measured many resistances before in this daughter cyst we found a resistive index that was very low. When we looked at the total data set, we found that resistive indices varied all over the place in patients with ovarian neoplasia and other types of lesions. So, the problem that we have with resistive indices is that the primary diagnosis drives the second order test. This is what statisticians call verification bias. Now you may be saying to yourself, well, Dr. Feli, of course, you might find differing resistive indices within the confines of a large mass. Well, certainly I would agree with that. And in fact, our study documented it. But here we have a patient with this lesion, which has a significant mural nodule. We'd all be concerned about that. And within the confines of that single mural nodule, we recorded resistive indices of 33, 50, and 67. Those are quite a spread from well into the benign range to significantly into the potentially malignant range. Here's a lesion that I showed you. So you measure your first resistive index at 70. So you say, I'll measure another one, 65. You measure a third one, 60. So you say to yourself, okay, well, how many more am I going to measure? Ridiculous. I'm not going to measure more. These say benign. This says benign. Here we see this patient. Your first one is 60. The next one's 55. You're going to keep measuring until you get one in the malignant range. Verification bias. So, look, Here's a patient that has this lesion that has, again, typically a mucinous looking lesion, has multiple septations, daughter cysts, septal nodules. We would be concerned that this is malignant, and we measure a resistive index and get 25. We're pretty happy with that. Here's a patient with a solid lesion. The color Doppler shows these vessels within it. It's solid. And we measure resistance, but it's greater than 40. This was cancer. And not only was it cancer, but it was metastatic cancer. So not a primary lesion to the ovary, but a metastatic lesion. Here was the lesion that I showed you earlier, the solid mass that was the smallest ovarian cancer that I found. My rule being that all solid lesions belong in a pan. But if I went on the basis of this resistive index, I would have said, no, it's benign. Clearly wrong. Remember this one. This was that borderline cancer that was a unilocular cyst. Now, the unilocular cyst is greater than 10 centimeters, but this was a lesson that I had to learn, that this lesion, lesions over 10 centimeters, I will add to my report. It could potentially be a borderline cancer. But had I looked at the resistive index, it would just convince me further that this was a benign lesion. It didn't help me. Now here is a lesion that if you see a lesion with a septation in it that looks like that, you're thinking cancer, cancer, cancer. But again, this lesion had a resistive index of 50. This is another low malignancy potential lesion, but I don't know what else to tell you. You know, if I see a lesion like that, I'm going to think flagrant cancer every time.